Hello everyone, this is the video 1 of Smart Road Collision Detection and Notification System for Computer Technology Project 1. And I'm Rashmi Hevage and I'm studying in the final year of BSc Computer Systems and Networking. And in this presentation, I will be introducing the topic, objectives and also the device placement, and my friend Vihanga will continue with the rest of the presentation. Over the years, the number of vehicle accidents have increased due to various reasons, and the current procedure that is being followed when an accident occurs is to dial the hotline and inform the authorities by a person that was nearby when the accident took place. And in here, the person who dialed the authorities should be able to give the exact location and also sometimes other information like the nearest police station or the hospital. And then they will report to the nearest police station that the accident took place in. After that only an ambulance will be dispatched if needed. So in this procedure, all the information given, including the location that the accident took place, depends on the random person who informed the authorities. And in this case, if the person is not good at giving directions, this can be a really time-consuming procedure. And because of this, time that can be used to save a life is lost, as the next half an hour is highly crucial for the people who are injured in the accident. Furthermore, one of the most major problems with this procedure is that 40% of the fatal car accidents occur at night, even though the traffic is less. So in this case, there may or may not be a person who witnessed this, or even those who passed by, resulting in loss of lives in the worst case scenario. There also can be issues in recording the accidents due to variations between the information that was provided. And by taking all these issues into consideration, we attempt to build Smart Road Collision Detection and Notification System to avoid all these errors by giving the exact location where the accident took place to the relevant authorities through a message. The main objectives of this system are to save lives when accidents occur by giving the coordinates of the place it occurred directly to the authorities, as it saves more time than the current procedure that is being carried out. And in here, the place of the accident is easily identified by the authorities, and it also makes the procedure faster and more efficient as well as reliable, as it does not depend on the information given by a random person. Moving on to device placement. In here, the weight sensor on the car seat signals the ECU, electronic control unit, about the occupant's weight, and then the ECU sends the data to the airbag control unit, which then turns the airbag on or off. If an ECU is not present, it will send the data straight to the airbag control module. And from the seatbelt buckle switch, it is indicated whether the occupant has put on the seatbelt or not, which is important when a crash occurs, because the signal taken from the crash sensors as well as the signal generated due to the tension in the seat belt is taken to the airbag control unit, which will send the signal to the airbag modules so that airbags will get deployed. And if there is an ECU present, an electronic control unit, it will send the signal to the ECU saying airbags have been deployed. And then the ECU will send the signal to the dashboard to turn on the indicator. If not, the airbag control module will send a signal straight to the dashboard. And the green circle indicated on the diagram shows the place that the input signal for the device will be taken from after identifying the wire which carries the signal we want. And Vihanga will give you more information on the product components, the problems we will face, and also about the timeline.
The main components that were required to build this system were an Arduino board, a GPS module, a GSM module, model number SIM900, a current sensor, and a few transistors and resistors. The Arduino board keeps all of the system's hardware components connected to each other. It is more like the fundamental platform of this system. The GPS module is used to get the location of the accident, and the GSM module is used to send this location to the user-defined numbers saved in the SIM card of the GSM module. The current sensor takes the input for this system. When an accident takes place, the sensors of the vehicle will detect it and will send a signal to deploy the airbags. When an airbag is deployed, the signal is also sent to the vehicle's dashboard. This signal will be detected by the current sensor. This is the 3D model of our system designed from SketchUp. As I mentioned in the earlier slide, it consists of these components. As you all can see, this is the Arduino board. It is powered up by the vehicle's battery. This is the GPS module and this is the GSM module with the SIM card on it. And this is the current sensor. We have planned to make this case from fiber with some thickness in the walls, so the components can be safely placed inside. So this is a rough sketch of how our final prototype will look like. There are a few problems we found out which we will assume to affect our system. Faults in the vehicle can occur at any given time, such as problems with the airbags and faults in the control unit of the vehicle, which will lead to our input signal to be undetected. The input signal will also be undetected if there are problems with the crash sensors of the vehicle, or might be even the current sensor which takes the input to our system. There are so many models of the current sensors available, but according to our design, we have to select the most suitable sensor for our application. Moving on to the timeline, this is how we planned our work through a 14-week period. In the first week, we gathered the relevant components. Weeks 2 to 5 were dedicated for code writing. During this period, we will also learn about our components much more in detail. In week 6 to 8, we will assemble the components and will try to fix any errors we come up with. Weeks 9 and 10 is for further error checking. Weeks 11 and 12 is for the finishing touches, and weeks 13 and 14 is to test the prototype in our test environment. So along with that slide, we have come to the end of our presentation. We will present more about this project in the next videos. Hope you all enjoyed it. Thank you.